Welcome to the Build, Create and Learn a Maker's Journey podcast. I'm Stefan and this is your behind-the-scene pass to my workbench. We will explore bringing ideas to life in the tech world, from hardware and software to product design and development, all as a curious maker figuring things out. I'm currently not an expert in every field, but I'm incredibly eager to learn. In this very first episode, we're kicking things off with my current big project, building a custom FPV drone telemetry system. We will talk about the idea, the initial and sometimes overwhelming hardware choices, and what I'm hoping to accomplish along the way. So let's start at the beginning. If you've ever seen an FPV drone, you know they are incredible machines for acrobatic and racing flights. I fly a custom-built FPV drone myself, and unlike the standard off-the-shelf models you've seen from brands like DJI, my setup doesn't have the luxury like built-in GPS modules. While I love the raw flight experience, there was always something missing. During my flight sessions, I often found myself wondering how fast I'm really going right now and how high did I actually get. My goggles, designed for piloting, just didn't give me that kind of true crucial technical details. This curiosity, this desire to quantify my flights sparked an idea. What if I could build a small device, something that I could attach to my drone that would collect this data, speed, altitude, position, and then transmit it wirelessly to the ground station where I can see it, log it, and analyze it. The thought of building such a device was incredibly fascinating. It immediately threw me into a world of new topics I little know about. LoRa communication for long-range data transmission, deep dive embedded programming, working with microcontrollers. It felt like a huge mountain to climb. But honestly, that challenge, that opportunity to learn so many new things, it's exactly what drew me in. Now you might be asking, why go through all this effort, especially if you're not already an expert? And that brings me to the why behind a maker's journey. For me, learning in public is more than just documenting what I do. It's about showing that this journey is accessible for everyone. There is no secret sauce, no magic talent required. It's about having the right mindset, the willingness to constantly learn new topics, and the persistence to push through when things get tough. I want to inspire people, not brag. My vision for this project is indeed to create a functional small device. And who knows, if other drone pilots find it generally useful, maybe it could be even evolve into a real product down the line. But honestly, that's not my primary goal right now. My main motivation is to shift just from watching amazing creators on YouTube, learning and exploring new things, to actually doing it myself. And more importantly, to take you on that journey with me. I know that with my broad range of interests, from product management to design to software and hardware, my content probably won't be for everyone. But I truly believe that there are like-minded people out there who can appreciate this messy and exciting path of discovery. So with the idea solidifying and the why in my mind, the very first tangible step was to selecting the hardware. And let me tell you, this was an overwhelming step. You envision the functionality you need, a chip for this, a sensor for that, but then you hit the online stores and realize there is literally trillions of options, countless of vendors and so many models. My decisions at that stage were definitely not guided by proper experience or data-driven analysis. It was mostly based on LLM recommendations, popular tutorials from other makers, and sometimes, frankly, just the pure availability of the certain chip on a development board in the online store I could actually purchase from. I don't really have a good understanding yet of how many capacity or processing power my device will ultimately need, so I just had to start somewhere. Here is what I picked so far. First, the microcontroller board. I went with the Nucleo 64 board, especially the STM ARM Cortex M4F11RE. I chose this Nucleo board because it comes with an integrated ST-Link, which is super useful for programming the microcontroller directly on the board. And as a newbie to STM32, this onboard debugger is a godsend. And why STM32? Well, after playing around with the Arduino and the ESP32, it felt like a logical next step to me. I've always wanted to really dig into the STM32. Next, for environmental data, I picked the BME280. This is a fantastic 3-in-1 chip that measures humidity, air pressure and temperature. It was one of the most recommended options for a use case like mine and comes at a low price, which is always a bonus when you're experimenting. For motion and orientation, I have the MPU6050 module, which integrates a 3-axis accelerometer and a 3-axis gyroscope. Again, nothing particular groundbreaking here. It was widely recommended. I'm sure there are better options out there, but for getting started, it seems like a solid choice. And finally, for GPS, I have a breakout board with the MTK3333 chipset. This is a high-quality GPS model that supports up to 22 satellites and 66 channels. This one was honestly the only cheaper GPS models available in the stores where I purchased all the other parts. GPS models in general can be quite expensive, and my goal was to keep the initial costs low because I'm still in the minimal viable product phase and constantly experimenting. Price was definitely a key decision point here. You might notice something missing, a LoRa module. That's intentional. The LoRa communication for sending data to the ground station is planned only for the next iteration of this device. First, I really want to see all the other basic things working, getting the sensor data, processing it, and getting the GPS coordinates, one step at a time. Now, when it comes to start a new project like this, especially with component selection, there are always hopes and fears. My main fear is definitely that the selected components just won't work with the intended use case. I've done my best with assumptions, but it's entirely possible some don't work with the communication protocols I need, or simply won't play nice with the microcontroller at all. I guess I will see. But my biggest hope for this project, beyond the drone itself, is to get truly familiar with embedded programming. I want to build a foundational understanding that will lead me to more projects in the future. To commit to this, I actually just completely reorganized my electronics workbench, tidied everything up nicely. It's a big step for me because with my mechanical engineering brain, I historically avoided electronics. It wasn't my preferred subject in school, but I truly believe that nowadays to build truly great devices, they need to be not only mechanical functional, but also intelligent inside, powered by microcontrollers or embedded Linux systems. This project is my first dive into that world. So, as we wrap up the first episode, here's the foundation I wanted to lay for anyone listening, especially if you're thinking of starting your own project but feeling overwhelmed. Just get your first development board and start tinkering around. Don't be afraid to dig into datasheets. With the knowledge of the right memory map and enough curiosity, you would be surprised what you can figure out. And even if you don't have exactly which parts to begin your project with, start with the requirements. What should the device or project do or fulfill? Going from there, search online, ask ChatGPT or your other preferred LLM to help you set up, but always have a clear understanding of your own requirements, what and how it should do. That's it for episode 1 of Build, Create and Learn a Maker's Journey. Next time we will dive into setting up the STM32Cube IDE development environment and maybe even get our first blinky LED working, the universal hello world for embedded systems. Thank you for joining me on this journey. If you're building something or learning something new, I would love to hear about it. Connect with me on LinkedIn or let me know what you're currently working on.